Welcome to Breadboarding. This is part 2 of video 12 in the Breadboard video controller series. In this video, what I'll be doing is just updating you on some of the progress I've made over the last number of weeks. Apologies for the day, I have been on holiday and there's been Easter vacations over in the UK as well. What I'm going to show you now is what I've been doing with the software to try and get a sort of representation of the classic Atari Lunar Lander game that I discussed in the first part of the video. So those of you who may not have seen earlier videos, this is the main Nanocomp breadboard computer. So this is the original Nanocomp with its keypad and LED display. And over here is the VGA controller that I've built up over the last 12 videos. This is now currently configured to be black and white 640 by 480 color graphics, which should be just about enough to do Lunar Lander. Now in the previous video, part 1, I did discuss the original Lunar Lander. It was actually built using vector graphics, and it actually made use of specialized hardware that drew the lines on the CRT display, and it didn't build up the picture using raster lines like standard TVs and modern monitors do. So this has made it a little more tricky for me to do this. So I'll talk about this as we go through, showing some of the stages that I've used to try and build up the basic physics of being able to update the screen fast enough to be able to do a playable game. The only update to the hardware I have done in this part of the video is over here. What I have done is unplugged one of the dividers which gave us the 9600 baud rate for the serial connection, and I've wired it directly into the clock here. This means that it now runs at about 57k, so it was taking quite a long time to download some of the software here, so this is now running about 4 times faster, so it's quite a bit faster. I might have a look sometime in later videos to see if we can make it run even faster, but it's fast enough for the moment. So that's the only real change we've made to the hardware since the previous video. So I'm just going to start with the program that we used in the previous video. So this is a Lander 1, as I've called it. I'm just going to send this down to the Nanocomp. I won't show the sending the files down to the Nanocomp for all the later updates. Okay, so that has now loaded. So here's the VGA capture card, and after reset and power on, it's all white, and all I'm going to do now is to run Lander 1. This one starts at 1000. And you can see here that I was drawing out the individual lander images here with the rotation, and this is using the transformations, the cosines and sine transformations I was talking about in the first video. This is the first version of the small and large designs that I did, and this is where we left off the previous video. So now I'm going to show you Lander 2. So this is very similar, apart from now we've added some exhaust or flames coming out the back. So this is just been extending the vectors used to draw these particular characters. And you can see that the landers here, really, that the speed of doing this by drawing the lines as the JavaScript demo program that I showed is not really an option. So that's Lander 2. Now Lander 3. And what I've done here is just tried to animate the flames once they're drawn on one of the small landers, just to see how realistic it would be to update the screen using the vector drawing of the lines when it's actually running. So you'll see one of the middle landers will animate the flames in a second. And you can see there that it's a little bit sluggish. You can see the clearing and setting of the different lengths of flames, so I'm not sure that drawing the lines in using the plotting functions that I had in earlier videos is really going to be a runner for this, so we're going to have to come up with something else. So for Lander 4, what I've got is I've actually hooked up the serial port as a debug console. So once we've seen the updating the screen, you see it's very, very slow at the moment, and the reason for that, if I just go back to sharing the main screen here, you can see that in the output, the console output here in the terminal emulator over the serial port is showing that I've got debug messages going. So the reason why this is going quite slowly is because it's outputting debug messages here, but this has been really useful to get to the bottom of some of the more tricky to resolve bugs here. And you can see that this is taking the image that was already drawn in the video RAM and then just moving it down one row at a time. Now, the only problem with this is that this won't be able to accommodate things like rotating the craft and moving horizontally 1 pixel at a time, for example, left and right, it was only sufficient to be able to move it up and down. But it was just to see how quickly you could move things using the C code that I was using here. It's Lunar Lander 5. It's similar technique, but a little bit faster. So speeded this up with a little bit of optimization. And you can see now that it's not doing quite so much debug messages, and it's moving a little bit faster. Around this sort of time, I also started to redesign the Lander style, making it closer to the original Lander game. And in the next video, we'll be seeing the revised design of the Landers. So what I decided to do with the Lander 6 was I actually drew the various rotations of the Landers, and also with different offsets. So an offset between the bits 0 to 7 across the first byte. Rather than having to plot each lander using the vector instructions that this is doing, what this allows us to do is to capture these images. And in fact, what you'll see a little bit later in the debug output, you can see that I'm outputting the binary values for each of these lander representations, so they can be stored in an array which we can then use for displaying the landers more quickly. So effectively all the calculations and the cosines and sines transformations that are going on here, we only need to do once actually at design time here, and then once we store these pre-calculated values in the program code, then it should be a lot faster to provide the updates to the screen. So this is doing it for the large lander, and once we've done all 10 or 11 rotations for the large lander, it will then go on and do the small lander. And what I will do then is to show you the debug output where the code necessary to populate the arrays in the C code are generated from this step here. So now it's doing the small lander, which is slightly faster. So this overall process takes about 2.5–3 minutes for all of these things. So this is the effort that's necessary for this 1 megahertz clock processor, 8-bit processor. Doesn't really have the horsepower to do this. Obviously the JavaScript Lander version that runs on modern computers can get away with plotting the vectors for all these landers and things, because it's running probably 1,000 to 5,000 times faster than this particular processor. But once we've captured all of these raster images here, we should then be able to update the screen a lot faster, and we won't have to do the calculations to decide which rotation we want to show. We'll just decide which rotation is and then just display that bitmap raster. So it's just about finishing now. So once this is done, what it's now going to do is to start outputting the code. So you can see here, this is each of the different orientations of the landers has been output into code that can just be pasted straight into a header file and is included in the next versions of the lander. So having now captured the raster images of the various orientations of landers and various offsets from the left-hand side of the first byte, this is then a simple test which is taking one of these and actually moving it across the screen. So this is moving it across 1 pixel at a time. So it's a little bit sluggish, this one at the top here, and then there's a couple of other examples of moving it down the screen where you'll see there'll be some artifacts and things which I went on to then correct in later versions, and also able to show how the lander can rotate according to how the navigation keys are pressed, so that you can direct the thrust vector when you're trying to land the thing. So you can see also here that there's a bit of the interference of snow from updating the video RAM, and then you can see here it is moving it down, but some of the logic in the code at this point in time wasn't quite right, and so it wasn't handling the situations when the lander was starting at a row other than the top of the byte on each character row. And then finally here you can see this is just the example of rotating from the full negative to full positive angles. So this is going from 5 in the middle, 0 on this side, and 10 or 11 on the right hand side there. So this shows that the raster images should be capable of being updated more quickly. We do need to optimize the code used for updating this. Then this next version, this is Lander 8. What this is doing is dumping out the raster images stored in the array, so you can see that's going a lot quicker, and then it's trying to display one lander, small lander on the right there. Now you can see the code at the moment is not quite right, and it took me a day or so to debug this to make sure under all situations this is coming out correctly. There's various complications. For example, we're going from page 0 to page 1 around this part of the page, around a third of the way down the page, and so there's quite a few complications necessary with the way how the video memory is mapped for doing these raster images. The next one, we've managed to address those problems. So Lander 9, what I've now done is created a zoomed landscape which will be appropriate for using with the large lander in the next version here, and I've also got the small lander doing a diagonal descent, although it is actually going through the landscape at the moment. But you can see here this is going 1 pixel at a time. There's a bit of flicker there, but it's moving a fair bit quicker than earlier versions. So this is making use of the small raster image. And so then what I'm going to show you now is the final version I've got to so far, which has got both the small and the large lander moving at a reasonable rate. There's still quite a lot of scope for optimization. This is all written in C, so it may be that we need to rewrite some parts in assembler to actually get the performance up. But one of the things we should bear in mind is that the original Lander game, because it drew all the lines using hardware, using the special XY display rather than using a normal raster display, what we're trying to do here by displaying raster lines is an awful lot harder work for the computer to do than it would have been using the dedicated XY plotting hardware. So this is now Lander 11. So this is showing a small lander moving at 1 pixel per step. You can see there's a bit of flicker there. There's no coordination with video blanking periods or anything like that at the moment, but you can see that it actually is able to move down the screen at a reasonable rate, and then it will land. And then I've also done the large lander for when we want to zoom in during a landing. This is shown here. So the large lander requires about 96 bytes to be refreshed for every time we move the lander. The small lander, I think, is about 48 bytes, gets moved every single time. So this is having to move quite a lot of data around the place. It's also having to calculate all the video RAM addressing, which is quite complicated to move down the screen, particularly as we go between the various graphic pages that we have. So what this shows now is that I'm able to use the 6809 running at 1 megahertz to update the screen fast enough to be able to make it sort of reasonably playable, not quite up to the speed of the original Lander game, but that's down to the dedicated XY plotting hardware used by the original Lander games. And what we'll also be able to look at in future videos, I may look at upgrading the processor to a faster processor, and there's certainly plenty of optimization we can do around the C code and replacing C with assembler. So what I'm going to do now is going to convert a lot of the JavaScript code that was in the original demo Lander that I showed in the previous video. I'm going to try and get that to run under this environment. I now know that I can display the landscape and display Lander. We may need to make a few simplifications, so I suspect I'm not going to scroll the landscape left and right. I just want to get a basic Lander working with thrust and rotate left and right, and then I think what I'll do is, rather than spending all my time doing the software, I'll go on and do the later phases of the graphics card build. I've still got a few other things I want to do with that, and then we'll come back to the Lander game in a number of weeks or months time, so I may very well work on the Lander code whilst I do the rest of the hardware. So thanks for watching. If you don't want to miss out on future videos, please hit subscribe, and if you found it interesting and useful, please hit like as well. Thanks for watching.